Today we are going to be investigating phytoremediation and why it is so important. Phytoremediation means using plants to reverse or stop environmental damage that can harm animals and humans. It is similar to using a vacuum on a dirty carpet or a mop on a dirty floor, except phytoremediation cleans dirty soil and water. Plants like poplar and willow eat up the chemicals and turn them into less harmful substances. Phytoremediation cleans up heavy metals like zinc, lead, and mercury, as well as harmful toxic substances like crude oil, dry cleaning chemicals, and explosives. These chemicals are absorbed through the roots of the trees and travel through its branch system like a bloodstream to accumulate in the leaves and branches. Maddie will now discuss the limitations and real-life examples of phytoremediation.
Thank you, Maeve. Some of the limitations of phytoremediation include the following. It is limited to shallow soils only and depends on the depth of root structure. The chemical may also be too toxic for the plant if it is highly concentrated. Phytoremediation also takes a long time and may transfer some of the contaminants from the soil to the air. The following 4 slides show real-life examples of phytoremediation sites from around the world. Over to you, Grant.
Thanks, Maddie. Because this is an engineering application, let's talk design. Our technology is in this case the plants used for phytoremediation. One consideration is typical root depth. This is how far into the soil roots can go. Plants can only clean what they can reach. Next is root type. Because different root structures absorb molecules differently, different plants might be needed in phytoremediation. Hardiness is the areas which plants can grow. Different plants grow best in certain areas of the country. Choosing the right plant for the job is crucial. Plant type, like trees, grasses, shrubs, perennials, and aquatic plants, are necessary to be considered. Growth rate. Depending on how long you can wait, you might want a slower or faster growing plant. With our technology comes site application. First, what will the land be used for? What was it used for? Biomass disposal is what you will do with the plants after they've been used for phytoremediation. How will you get rid of them after they've done their job? What contaminant is present at the site? This is crucial in determining what plants can handle which kinds of contaminants and which contaminants might be better suited for another technology. How does water interact with the site? This might be necessary if there's standing water or groundwater that needs to be considered with contaminants. The technology train is what other technology can be used in addition to phytoremediation at the site. And last, how big is the site? Are we planting a field, managing a wetland, or creating a forest? We hope you liked this presentation. Please learn more how to solve the Earth's puzzles.